Alright guys, well we're back out here in the shop again today, and as you can see I've got the gearbox off that has all of the speeds and feeds. Well, actually it's just for the feeds of the carriage, and the cross slide it also has cross slide feed. So all this gearing in here is for the feed, you know, for the lead screw on the side, which I have all of this come off all at one time, kinda. So as you can see, that machine surface goes all the way down to the end, so it'll give me a good reference surface to work with for mounting the ball screw on the side of the machine, and also mounting all of my bearing block and motor mounting stuff and everything. I can do all that down here. And the object, well, what I had planned on doing is, when I build the enclosure, is using this surface to kind of keep everything behind this surface, and then from here back this way would be, you know, in the enclosure where all of the coolant and everything that could mess up anything would be. So I'll have a wall here, and it'll have to be so that the bearing block and everything seals against this wall. So it's going to be kind of a little separation there to keep everything out of the coolant and everything over this way, and keep everything that don't need to get wet back on that side. So that's kind of a good thing. I was hoping this gearbox wasn't made into the casting here, and it was not. It had 4 bolts in it here, and I took those out and it came right off. After I took the bolt out of this right here is for tensioning or setting the gap in the teeth here for the drive, which drives everything on the inside. So whenever you move these things around, it causes, that gear set causes all of that to drive. So, which in turn turns all of this stuff here, which this one is this is for the cross feeds and stuff like that, for the upper cross slide feed. And then this drove the lead screw. This was just a piece of hex bar that ran all the way down, and it was tied into the carriage or apron, everything that was behind the apron, which all of that came off. From here down was where the apron was, and it all came off one piece. So it's back here, and all of the drive mechanism is down there. The lower one down there, right there, is where the hex bar went through. You can probably see it. And the threaded lead screw went through that hole. You can see the separated nut all the way through there. There it is back there, the separated nut. So when you move that handle right there, whichever way you move this handle up or down, or this handle here does what engages this split nut against the lead screw. What this does is engages your feed. You can pull it out and turn it, and it's linear, and then pull it out and turn it again, and it's cross slide. So all this gear set in here does is engages with this gear in the back, turns all the time, and then this one disengages and engages according to when you pull this lever and which way it's oriented. So all of that junk back there came off of this. It was all the electronics that was inside this casting right here. This is a through passage right here to the back where the electrical panel was for the DC motor drive and all of that. The little hole up at the top was actually a RPM gauge. This spindle has 4 of these little magnets embedded into the spindle all the way around, so it was getting four blips from the spindle shaft to keep up with the RPM, which I thought was I thought it might be useful, but if you're running encoder you don't have to have these magnets, so I just took it all off, and it might come in handy for using it somewhere else on something else some other time, or maybe somebody may need it or something for their project or something. You never know. But anyway, that's the 4 magnets. It would come around. It's kind of less like a Hall sensor. It would send 4 pulses to the board that was controlling the RPM for this machine. So that's kind of good. That's more than normal. Most time all you see is like 1 pulse. So I thought that was intriguing as well. It's kind of, it's like the deeper I go, the more good features I find about the standard machine that was here originally. So, but a nice encoder is going to be hard to beat. So that's which way I'm headed, is try to use an encoder, so it'll have a lot more resolution than 4 blips. So with that being said, and this surface right here is going to be coming in real handy about registering everything. So, and I think a buddy of mine was asking me about the direct drive from the factory. As you can see, this is all just tumbler gears here for it's all for the driving of that gearbox that was down below. So all this stuff will come off, and it's just going to provide places to bolt. I won't have to drill and tap any holes. So there'll be plenty of places to bolt to make a bracket for a encoder bracket or something, you know, to fasten it up here. And this little dude right here, which is a drive gear for all of the gearing down here, this little guy, being as it's here, I'm pretty sure this will just bump right off here, and there's a key trapped in here, and this will slide right off. So possibly if I can get aluminum or something to go on here to drive my encoder with, all this will be pretty easily reincorporated with what I need. So that's kind of a break with all of that. And I'm guessing that's probably just about all there is to brag about this time, which is not a whole lot to brag about. But anyway, something's happened to my camera here. I think it's flipped out. I see what I did. I zoomed in too far. Okay. Anyway, not a whole lot to brag about, except for I like the registered surface here. This is going to help out quite a bit. And I already got drilled and tapped holes. I can just mount me a plate there and be in good shape. So, alright guys, well, coming along. Not a whole lot of room to work with right now, trying to do all this stuff. Get it where I can move it around, and once I get it where I can move it around, it'll be a lot easier to put in my pan that I'm gonna build a pan, and then I can just fasten the enclosure to the pan, so to speak. and I think it'll be alright. It'll be a lot better than just having this tray. I mean, this tray is all bent up anyway from where it got damaged the first time it got shipped. So it's bent pretty bad on the tailstock end. The headstock end's not too bad, but the tailstock end's got pretty bad bend in it. It's not really flat, so I'm not thinking it would work too good. And I'd much rather have a really nice floor in the enclosure, so it'll help make it a lot more stable. Give me a nice piece of plate, make the floor out of, and then just create a pan and then build from that. Kind of make it serviceable. Alright guys, well, not a whole lot this time, but we did make some progress. It's got a pretty beefy compound miter here. That thing's pretty solid. I was kind of impressed. This is almost as big as my cross feed on my little lathe. So it's almost like having a little lathe on top of a big lathe. Alright guys, that's it. I'm going to quit blabbing now. And more progress I make, the more videos I'll post. But that was a couple of highlights that I wanted to point out that did come true. So that's going to make it a lot easier about putting everything in place. It seems to be, everything seems to be really smooth. Figure this apron plate out here and get the ball screw mounted on here as soon as I get it and get everything figured out. Alright, well, I'll keep you guys updated, and like I say, subscribers welcome, and thanks for watching the video. Thumbs up if you like the video. I know it's a little crude, handheld and all, but I don't have a whole lot of room for a tripod, so, and it's hard to get at all these little areas underneath all these ledges and stuff. So maybe things will get a little smoother once I get it up higher and start working on the enclosure and start putting the electronics in everything and get all that set up, and I'll be up a little higher. Maybe I can use the tripod then and it'll be a lot smoother. Alright guys, take it easy.